Okay, this section is about sequences, and the next section is series. And we did this last year in Algebra 2. So the first part, it will feel like, or actually most of it will feel like review. So first, sequences. Sequences is a list. I'm sorry, a list of numbers. So usually we list them down like 1, 2, 3, 4, 5, or 2, 4, 6, 8, 10. So it's a list of numbers. And series is the sum of the sequence. So 1 plus 2 plus 3 plus 4, or 2 plus 4 plus 6 plus 8, and so on. Infinite series or sequences basically has no end. So you'll see them, you can distinguish them because when you see the series, it will say 1, 2, 3, and then goes dot, dot, dot. When you see the dot, 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 you know that it means infinite. And finite, no, you know that it has an end because it would just say 1, 2, 3, and then it ends. Okay, so what I want you to do is pause the video, and I want you to determine which one is a series and which one is a sequence, and whether it's infinite or finite. Okay, so pause this video, give this a try, and then come back and check your answer. Okay, so please go ahead and check your answers and see if you got them right. Now there's some formula, and since we already went over this last year, I'm just going to give you the formula. So go ahead and copy them down, and then we're going to just talk about how to use them. So arithmetic. There are two kinds of sequences. So today we're only going to talk about sequences, and then we're going to spend 2 days on series. Arithmetic sequence means that it's a sequence where the next number can be obtained by adding a common difference. Common difference, difference doesn't always mean subtract. Difference just means that you're going to get to the next number by subtracting a number, whether that number itself is positive or negative. And we call this common difference D. So what you want to remember is that you can get to the next number by adding or subtracting. Okay, and then we call this arithmetic sequence. And geometric is where you can get to the next number by multiplying a common ratio. And we call that common ratio R. Again, so when we say ratio, it's going to be some kind of fraction, but basically you multiply by a number, and then that number can be a fraction to get to the next number. So what you want to remember is you are going to get to the next number by dividing or multiplying. So one of them is adding and subtracting, the other one is multiplying or dividing. All right, so let's look at these problems. For each of the following sequences, find A, the common difference or ratio, B, the 10th term, C, a recursive rule for the nth term, D, an explicit rule for the nth term, and E, graph the explicit formula. All right, so let me give you the formula first. Arithmetic sequence, explicit formula. The reason it's called explicit formula is that you only need the term number to figure out what the actual number is. When we say term number, so for example, if you have a sequence like 1, 2, 3, 4, 5, and you say this number 1 is the first number, you would call it A1. The second number, you call it A2, A3, A4, A5. Okay, so like that. And then this 1 is called the term number, but the actual number is 1. And this one's a little bit confusing because the term number and the actual number is the same. So let's say, for example, you have something like, 2, 4, 6, 8, 10. Then you can say the first number is 2, but the term number is 1. And then so it goes A1, A2, A3, A4, A5. So you can see that this is called the term number and this is the actual number. So explicit formula for an arithmetic sequence is an equals to A1, so that's the first number, plus plus d times n minus 1. Okay, so to get to whatever n number you want, you take the first number plus the difference times n minus 1. And we don't have a lot of time to kind of derive why this formula works the way it does. But if you want, you can go back to last year's notes where I did take some time to derive it. And hopefully that will make more sense once you see why the formula is the way it is. Recursive formula means depending on the previous term. So it's like recurring. So recursive formula is an equal to the previous term, n minus 1. So if the current term is n, then the one before that is going to be n minus 1. So you take the previous number and then you add d. That's how you're going to get to the next number. So that's pretty self-explanatory. So for example, if we look at this sequence here, and I ask you, how did you get to 8? You said, take the previous number and add 2. And I'm going to ask you, well, what is the previous number? And you're going to say, well, take the previous number and add 2. Well, this is not going to get anywhere if you don't tell me what the first number is, right? Because eventually you have to get to the first number. So in order to do this formula, you need two things. One, the recursive formula. Second, you need to tell me what A1 is. So you're going to fill it in. You're not going to leave it as a question mark, but you're going to tell me what A1 is. That way, the recursive formula actually can help you figure out what the next number is if you tell me where you start. Okay, let's talk about the geometric formula. Geometric explicit formula. So how do you get to that number by a term number? It's going to be an equals to the first number times r. But r is to the n minus 1. Okay, so you can go back to last year's notes and figure out why it has to be n minus 1. Basically, the gap between all the numbers in the sequence is always going to be the term number minus 1. So there's always one less than what the term number is in terms of gaps. Recursive formula is going to be an equals to the previous number times r. And again, you got to tell me what first number is, or else this formula would not be helpful at all. Okay, so make sure you copy all this down. Okay, so let's go ahead and solve a problem. So let's look at the first one. When they give you a sequence, what you want to do always is ask yourself, is this arithmetic or geometric? Am I adding and subtracting to get to the next number? Or am I multiplying or dividing? So you can see that this one is very clear. You are going to add 4 every time. So adding 4 is going to be arithmetic. So we would say D is 4. Okay. Oh, that is the first question, A. B. B says find the 10th term. Okay, you can see that this is A1, this is A2, A3, A4, A5, and this one, since there's just not a lot of numbers, you can just figure out A10 by keep adding 4, right? You can get to A10 very easily. But I'm going to show you how to do that with your explicit formula. So I'm going to skip ahead a little bit and let's do C first, recursive formula. So recursive formula is going to be take the previous number and then we're going to add 4. Then remember the second part is you got to tell me what A1 is, and in this case is negative 4. Okay, so that's part C. Part D, explicit formula. Explicit formula is going to be an equals to the first number. First number is negative 6, and then D is 4, so plus 4 times n minus 1. And you don't put anything in n because that is the variable. And so what you can do is we can simplify this a little bit so it's not so much stuff, I guess. So clunky. So we're gonna just change it so that it is simpler. Okay, now let's go back to B. B says, what is the 10th number? 10th number means n is 10. So what we want to do is take this explicit formula and just use that. Okay, A10 is equal to 4 times 10 minus 10. So that's going to be 30. And then you can use, your calculator to keep adding 4. When you're on the 10th number, it should give you 30. Okay, last one, E. Graph it. Okay, so now when you graph this, you're actually going to graph this 4n minus 10. Now you are not going to graph it in function because this is not a continuous line. Okay, 4n minus 10 sounds like a straight line, but it is not, because n is only integers, right? Because we are only talking about the first term, the second term, the third term. We're never going to say 1.125 term. So real numbers is not included in this sequence. So basically, n can only be integers. So this is not going to be a continuous line, meaning like it's not going to be a smooth line. It's just going to be a bunch of points. So to graph this, what I want you to do is go to mode. And then so this is where we're going to use our last type of graph on our calculator. So we're going to go down to where you had changed from function to parametric to polar. The last one should say something like SEQ for sequence. And then once you do that, you go to where you usually graph, and then now it's going to change into something that is very different. Okay, let me get out my calculator. So now you go to graphing, and you're going to see something like n, min equals 1. That one, you just leave it alone. And then it has like dot, 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 and then u of n equals, and then u of n min equals. Okay, so what you want to do is here, you're going to type in 4n minus 10. That is asking you, what is the function for this sequence? And then n min means what is your first number, or minimum n, or just, what is your first term number? So I'm going to say 1. I'm going to start graphing from 1. So now when you graph this, let me type this in myself, 4n minus 10. Okay, you should see something like this. Okay, so what's happening is it's graphing these points that's very discrete. So you told them to graph A1. So this point here is A1. This is A2. This is A3, A4. And so what happens is graphing all the integers, and this part, the y, just represents what the actual number is. So please do not draw lines through it. That makes no sense because you don't have any non-integer term numbers. Okay, so it is just discrete points. All right, let's look at the second example. Okay, this one's a little bit harder to see what kind of pattern it is. So you're going to ask yourself, how do I get to the next number? You can see that the numbers are going up by multiplying by 2. But it does have a natural log in front of it, so you can't really say that you get to the next number by multiplying by 2, because that doesn't work. That's not a log law. So what you can see is that basically what we're doing is we're multiplying by 2 inside, right? And then hopefully you remember that the log law says we are going to add them. When we multiply, it's the same as saying add. So this actually turns out to be an arithmetic series where d is natural log 2. Okay, so let's have you finish this problem and then come back and check it. Okay, so I've done up to just the formulas, and then so I want to show you how to do A10 if you haven't done that. A10 is going to be natural log 3 plus natural log 2 times 10 minus 1. So this is going to be natural log 3 plus natural log 2 times 9. Okay, natural log 3 plus natural log 18. And hopefully you remember that when you add, you are actually multiplying. So this is going to be natural log 54. And then E, you're just going to graph it. It's going to show you the same thing because this is linear. It's going to look like a straight line but not connected. All right, let's try another one. This one is pretty easy, so I'm going to let you do that on your own. This one is a little bit tricky. Okay, so ask yourself, what is the pattern? Is this arithmetic or geometric? Hopefully you can see that the exponents are going up by 2. Again, so what you want to ask yourself is, how do I actually have it go up by 2? Well, going up by 2 is the same thing as like this. You can split it. Okay, so not sure if you remember. If you have two exponents, let's do something that has numbers. 2 plus 1, for example, is 2 squared times 2 to the first. Okay, so you can split up adding and subtracting exponents like this. Okay, so you can see that we're actually going to multiply by 10 to the second, so that means r is 10 to the second. Okay, so that's part A. Okay, part B, again, we're going to come back later once we have the explicit formula. C is recursive, so an is equal to an minus 1 times r. R is 10 to the second. And then the first number is 10 to the negative 3. D. Explicit formula is an equals to the first number times r to the n minus 1. So this is pretty awkward. You can clean it up if you want. It's not really necessary, but let's just clean it up and so I can show you how to clean up exponents. So this is 10 to the negative 3. This one we're going to multiply through, and then like the trick I showed you before, we can split it up. Okay, now you can see that we all have a bunch of base 10s. So I'm going to combine the two that doesn't have variables together by adding them. Okay, please don't multiply them. All right, this is probably, I guess we can go one more step to make it the negative in the denominator, but I think it's probably not going to make too much difference. So I'm going to leave it like that. All right, so at this time, let's figure out what is A10, the 10th term. So that means this is 10 to the negative 5 times 10 to the 2 times 10. So this is 10 to the negative 5 times 10 to the 20. And when we multiply, we add the exponents together. So this is going to be 15. A10 is 10 to the 15. Now, when you put this in your calculator to graph, you'll see that this looks something like this. Sorry, we don't have any numbers. That is negative. Okay, so you'll see this graph looking like this. This is actually an exponential graph. And then you can see it from the function that something to the something, where that variable is in the exponent, means it's an exponential graph. When it's an exponential graph, it always has an exponential shape. Okay, so this is how the graph will always look like for all the geometric series. Okay, now you can give this one a try. This one's very simple, so just pause the video, do it, and then come back and check. All right, please double check your answers. Make sure they are all correct. Okay, let's look at a problem that's not so straightforward. The second and fifth terms of a sequence are 3 and 24, respectively. Find the explicit and recursive formula for the sequence if it is arithmetic or B, it is geometric. Because the type of sequence matter, and because it's gonna matter how you get to the next number, telling you that this second number is this or the fifth number is this doesn't really make any difference because you don't know how they were supposed, what happened to get to the number. So they have to tell you what kind of sequence it is. Okay, so let's solve it if it were arithmetic. So it tells us that the second number is 3. The fifth number is 24. So there's some numbers in between, A3 and A4. We don't know. Okay, but we know that we got to the next number by adding because it's arithmetic. So we know we add a D here, add a D here, add a D here. So to get from 3 to 24, we know that we added 3D so that we can get to 24. So then we can go back and solve for D. So D is 7. Now that we know that the number is 7, it's very easy to write this formula. Let's see. Explicit formula is a(n) equals to 3 plus 7 times n minus 1. And then the recursive formula is a(n) equals to the previous number plus 7. And the first number is, that's a great point. What's the first number? The one before that. So that is -4. Okay, now we are going to take the same sequence and then we are going to figure out what is it if it were actually geometric. If this were geometric, then we would have to multiply by r to get to the next number. So let's think about it. This is going to be 3 times r times r times r. That would give me 24, right? So this is really 3r cubed equals to 24. So what we can do is backwards solve this. So r cubed is equal to 8, r is equal to 2. All right, side note, and you probably have hopefully remember this from last year. If you got something like this, I don't know, like you got r to the 4th is equal to 16. Now you cannot assume that r is 2 because could be plus minus. So you'll have to solve for two different sequences if that were the case. So anytime you see a even power, you need to make sure you have plus minus. Or in this case, it is not. It is just r cubed equals a, so r is 2. So explicit formula is a(n) equals to 3 times 2 to the n minus 1. And then the recursive formula is a(n) equals to the previous number times 2. And then the first number, so to get to the first number, what you're going to do is, you multiply to get to the next number. So to go backwards, you're going to divide. So the first number is 3/2. All right, the next part is pretty easy. It's just that you probably never seen this notation before. So when they have something like this where they have two squigglies like that, this is called, this is basically telling you a sequence formula. And so what we're going to do is we're going to try to figure out the limit of the sequence, meaning what happens when n goes to infinity, when the term number goes super large. Well, two things can happen. One, it will become just one number. No matter how much further you go, it would just become one number, or it will get really close to a number. We call that converge. So it's going to converge to a number. And that number we call L for limit. If that limit is not infinite or non-existent, infinite means that it's infinitely large or infinitely negative, or it doesn't exist at all, we call this diverge. All right, so what we're going to do right now is figure out if it's going to converge or diverge. If it does converge, we have to tell them what number it is. All right, so remember, we are trying to figure out what happens when n goes to infinity. So let's look at this first sequence. 1 over 1, 1 over 2, 1 over 3, 1 over 4. And so what's happening is it's taking its term number and then taking 1 dividing by the term number. So essentially it is doing 1 over n. So what happens if n is super large, n is infinity? Well, this becomes 1 over infinity. Now, what is 1 over a super large number? So if you divide $1, you divide $1 to like 10 million people. How much does each person get? Almost 0. All right, so this actually converges to 0. This does converge, and it's converging to 0. What about this one? 2 over 1, 3 over 2, 4 over 3, 5 over 4. So ask yourself, what's going on? You can see that the top number is always 1 more than the bottom, right? Or sorry, the numerator is 1 more than the denominator. So what you can do is you can say that this is basically saying n plus 1 over n, right? And then so what happens when n goes to infinity? What happens when n is super large? Well, if n is super large, I think we talked about this before, the 1 is negligible. So this is like infinity over infinity. So it becomes 1. And later on, on the next page, what I'm going to show you is what you want to do is in the numerator, you pick the one that has the highest degree, and you pick the one on the bottom that has the highest degree, and you just compare, kind of like horizontal asymptote. So this is going to converge, and it's going to converge to 1. All right, so let's have you give the next two a try. So pause this video and make your best guess. All right, this 2, 4, 6, 8, 10 came up again. What do you think? Is it going to converge or diverge? This is actually going to diverge. So when the term number gets really big, your numbers just become bigger and bigger even numbers. So it's never going to come to just one number. It's going to be infinitely big and even. So nope, it's going to diverge. This one, this is kind of strange. Is it going to converge or diverge? Well, you can see that this is going to oscillate between 1 and -1, 1 and -1. So this is also going to diverge, or it's non-existent, because it oscillates. When it oscillates between two numbers, it never gets to a number, a single number, so we cannot say that it converges. All right, now we can see this notation that actually has a formula. So like I talked about on the previous page, so what do you want to do if you see this kind of problem? You pick the highest degree, or the one that moves the fastest in the numerator, and then do the same thing for the denominator, and then you compare. So in the numerator, this is the only thing, and in the denominator, n has the higher degree than 1. So then you're just going to compare 3n to n. And if you recall, this is just like horizontal asymptote. The 3 n cancels is 3. So it's going to converge to 3. All right, so let's have you guys give these ones a try. B, C, D, E. Pause this video and then come back and check it. All right, so I did B, C, E. C is going to diverge because if you look at the degrees, n cubed is bigger than n squared, so then eventually it would just be n, which n goes to infinity, it's going to diverge. D is a little bit tricky. So what happens when n goes to infinity? Well, 1 over infinity is going to be 0, so 2 to the 0 is going to be 1. So it's going to converge to 1.